100 trillion years from now, the biggest stars will be the first to go extinct. Big stars burn bright and die hard. The star's core collapses, unleashing a supernova. Then gravity crushes the dead star down to a single dense spot. The bright star is now a black hole. Medium-sized stars like our sun will go next. As its supply of hydrogen runs out, it swells to a bloated fireball over 200 times its current size.
And when the core has no more hydrogen, it's going to bloat up into a red giant star. Now, red giant stars are so big, they will actually eat up their own planets. We know of examples of red giants that go all the way out to where the orbit of Jupiter is in our solar system.
Its fuel exhausted, the sun gives in to gravity and shrinks to a white dwarf. A dense ball of matter just a few thousand miles in diameter. It will glow with heat for a further 10 billion years before cooling to a black dwarf, a ball of compressed carbon, perhaps even diamond. As the biggest stars die, the universe will slowly turn red.
The blue stars will blow up, and then the slightly less blue stars will blow up, and then stars like the sun will fade away and die, leaving just the red stars to exist.
Red stars are the smallest and coolest in the universe. They burn their fuel slowly. But after another 10 trillion years, even the smallest of dwarf stars will use up their fuel.
Stars, as we know them, will cease to burn energy, and the night sky will turn black.
Black holes, the corpses of dead stars, and cold clouds of gas and dust are all that remain. The age of stars is over. The age of black holes begins.
Black holes become the fundamental building block of the universe. A galaxy will basically be a supermassive black hole in a center with smaller black holes orbiting it.
In some ways, it's kind of a ghost universe. It's the corpses, the zombie stars, that will take us into the future.
Zombie galaxies filled with black holes continue to evolve. They sweep up the dead remains of stars. Black hole merges with black hole.
They'll eat each other and they'll get bigger, and maybe they'll fall into the supermassive black hole and it'll get bigger. The universe will still be an exciting, dynamic place. It's just that the timescales you're talking about are now trillions of years instead of thousands or millions of years.
Any matter that evades the pull of a black hole eventually dies away as its protons disintegrate.
A proton, one of the fundamental building blocks of atomic matter, of what makes us up, can just spontaneously fall apart. And it turns out this takes a tremendously long time, but even that will go away.
All that will be left is a sea of black holes. Scientists used to think black holes were immortal, but even these will one day die.
Now we're talking about timescales of unimaginable length, quadrillions of years into the future. But on that timescale, even the black holes begin to evaporate.
They'll get smaller and smaller and smaller, and then poof, they'll be gone.
The universe will end when the last remaining black hole dies. As it gets smaller, the evaporation rate increases exponentially. Before long, it reaches a size of a billionth of a trillionth of a trillionth of an inch. At that instant, the laws of physics break down, and the last black hole explodes in a flash of gamma rays, leaving nothing.
And it will die in a sudden burst of light, the last burst of light in the entire history of the universe.
The big freeze is coming. The universe will suffer a cold, slow, dark death, which will play out over trillions upon trillions of years. But quantum physics leaves the door open for an alternative end. An event so powerful, so destructive, that it could destroy everything we see in the blink of an eye. And it could happen tomorrow. The end of the universe is coming. Dark energy accelerates the space between galaxies, pushing everything we see to a long, cold, and very slow death. That's unless something bizarre happens first. A monster called phase transition lurks in the shadows, and it could annihilate the fabric of space and time at any moment.
When we cool down water, it turns into ice. The properties change. If you lived in the water, when it changed to ice, your world would be very different.
Water changes phase into ice when it loses energy.
I once left a water bottle in my car overnight. It was still liquid, but the moment I touched it, the slight imperfection, a little bit of ice that had formed, spread, poof, and filled up the whole bottle.
That rapid change to something new is called phase transition. And bizarrely, the same thing could happen to empty space.
We've really come to understand that we shouldn't take for granted that vacuum, what we call nothing, is actually stable.
It could be that the energy stored in empty space is just waiting to be released in a phase transition. If it is, the laws of physics will change.
A spontaneous glitch in the fabric of space-time could trigger a phase transition of space, a tiny bubble of new universe that spreads out, overriding the old. We know it can happen because it's happened before. At the moment of the Big Bang, the universe that's first created is completely different to the one we see today. Hot and without form, there's no matter, no time. The laws of physics are different. Suddenly, less than a trillionth of a second later, a glitch triggers a phase transition. A tiny bubble of the universe we live in today forms, and it races outwards, destroying everything it touches, like ice spreading through water. The energy that spills out creates the space and time we exist in, the building blocks of matter, and the forces that govern them.
All that energy was released, producing all the matter and radiation we observe in the universe today.
The old universe gives up its energy to create the new, but it holds some back. The vacuum of space still has energy bound to it. Perhaps this is the dark energy we see today. Physicists believe that someday in the future, a brand new glitch in the fabric of space-time may trigger another phase transition, one that wipes us and everything we see out of existence.
This is a way to destroy an entire universe, because within your universe are the seeds of its own destruction.
It would spread out at the speed of light in a death bubble, ruining all the galaxies as it passes through and ultimately completely destroying our universe.
Nothing can survive the expanding phase transition. Planets, nebulae, galaxies are all ripped apart as the boundary of the bubble reaches them.
Inside this bubble, protons are unstable, atoms begin to rearrange in a new form of matter. As these bubbles begin to expand, a new universe is being born in the corpse of the old universe and the beginning of a new law of physics.
And so, the expanding universe we now see may end in a phase transition, but we won't know what hit us because the laws of physics will change and we will essentially, most likely, disappear at the instant it happens.
This bubble will expand at the speed of light, and as the bubble passes you, all the atoms of your body rearrange themselves, and you would never know it. You would have no warning because the bubble itself is expanding at the speed of light.
You can't predict precisely when it could happen. You only have a probability. So what you really are predicting is a rate. Does it happen once a year, once every 10 billion years, once every Google years, or whatever? It's very possible that these bubbles get nucleated and grow about once every 10 or 20 billion years. So it hasn't happened yet, because we got lucky. It's unlikely it would happen the next year or the next day, but the laws of physics absolutely allow it.
A phase change may happen, or it may not. The universe plays its cards close to its chest. Unlike dark energy and dark matter, there may be more surprises still to come. Surprises that will only add to the mystery and wonder our universe holds for us.
Whatever the universe is up to, we still don't know enough. We're in an age of discovery right now. Perhaps there's something else out there that we don't know about. So I'm not going to draw any conclusions until things are conclusive.
We don't understand the nature of dark energy. And without that understanding, virtually anything is possible. The future is still uncertain, and that means there's still a mystery. And for me, that's the most exciting possibility of all.